Welcome to NTNU Evening. We are now in the 16th season of this event. The consequences of climate change have now become really clear to us. Nor does the Earth have unlimited resources that we can use and throw away. NTNU has many researchers working to find sustainable solutions and how we can succeed with the demanding changes that are needed. Tonight we are investigating the circular city. How can existing buildings and become a resource for reuse? What are the challenges? How to create sustainable buildings for the future? What does this mean? And we all say welcome to the listeners we have in the stream. And before we proceed, I will introduce to you NTNU's Pro-Rector for Research and Dissemination, Tor Grande. Please, stage is yours.
Thank you very much, and also thank you for the kind invitation. So, dear colleagues and friends of NTNU, NTNU Kveld or NTNU Evening is one of the most exciting arrangements at NTNU, contributing to the dissemination of the research conducted at NTNU. And tonight's program focuses on a topic of great importance for the future sustainable development. And as you will see soon, we will have the privilege to meet some of our young scientists at NTNU. So it's a great pleasure or honor for me as Pro-Rector for Research and Dissemination to be here tonight. It's also a great inspiration to listen to our prominent young scientists about their research. Yesterday we heard about hydropower, while today's topic is the circular city. How can existing buildings become a resource for reuse? And I'm very proud that we have started an interdisciplinary research program for sustainability at NTNU. And this program has been named Sustainable Research at NTNU, and it spans 11 different projects, including 47 doctorates over 4 years. And tonight, you will meet the researcher from one of these 11 projects, and they work with circular city. And the key elements when we selected these 11 projects were sustainable development, transformative research related to the green transition, and interdisciplinarity. So I'm really looking forward to learn more about these specific projects and to meet the project leader together with several of the prominent PhD candidates working in this cross-disciplinary team in the project. Thank you, and good luck to those coming on the scene tonight.
Thank you, Tor Grande. Pasi Aalto is project manager of the Circular City. He brings together many different perspectives to create the best possible development towards a fair, a circular, and a sustainable 2050 society. This means researchers, students, industry, the public sector, and other organizations. In this vision, existing buildings are a central part of the resource base, and Trondheim is a test arena, in the forefront. Pasi Aalto works at the Department of Architecture and Technology and is Center Manager for NTNU Wood. Please, Pasi, the stage is yours.
Thanks, Randi. Hello, everybody. So today I have the distinct pleasure of introducing you to the Circular City project. And I'm going to start off with a little story. So in 1901, the Norwegian government decided to have an architectural competition for what is today known as the main building of NTNU. And when the jury evaluated the proposals, they decided not to give out a first prize. The second prize went to Thorvald Astrup for his design, Daggry. We, however, decided not to build that. There was a cheaper option on third place by the architect Bredo Greve. Even in the technology capital of Norway, the discussion was about spires and poor aesthetics. What this shows is that the way our buildings end up being is a sum of deliberate and random acts by many individuals that hold a multitude of values to heart. Some of the buildings end up being cherished and stay with us for a long time. Others fade relatively quickly and become neglected. Today, only about 5% of the buildings in Trondheim are as old as the NTNU main building. Then, same as now, we use an astounding amount of resources towards our buildings. The building sector is known globally as the 40% industry because almost half of our energy and resources are going towards buildings. And what happens when society moves on and the buildings remain and they just fade into obsolescence? Well, the mantra of the Northern European construction sector has been to demolish, build something new. Obviously, we know today that that is very much at odds with the needs of the 2050 society. Instead of demolition, we need to maintain, adapt, salvage. Our buildings need to last a lot longer. And when they're no longer needed by society, they need to give up their parts to new buildings. In essence, we need circularity, and we need it most of all in our built environment. This change is very difficult. One major part of that difficulty is uncertainty. Now, Norway's been mapping its resources for decades. Oil, minerals, timber. But do you really know the resource base for a circular built environment? Do we really know how many doors, windows, bricks we have? If we don't know what we have and where we have it, how could we ever make an efficient strategy to salvage it? And even if we knew where we have it and what we have, we still have to make a just transition towards a sustainable society. Now, Circular City aims to build a research infrastructure that speeds up building this knowledge. Our goal is to gather as much information as we can about the 77,347 buildings in Trondheim. We're going to try to understand the building stock and the dynamics, and how people's actions affect that building stock. Now, this is an endeavor which is very complex, too complex for a single mindset. So NTNU has kindly agreed to let us put together an interdisciplinary team. So we have planning, architecture, engineering, geomatics, geography, industrial ecology, heritage, digital twins. Altogether now about 21 people are connected to our project. But we believe that is not enough. We need to understand the complexity of the city, and we need to understand what makes it tick. So our goal is also, how do we include new researchers, citizens, students? We need new people with new mindsets and new values to engage with circularity in the city. So today we're going to learn a little bit more about Trondheim. We're going to listen a little bit about the relationship between neighborhoods, buildings, and people. We're going to get to talk a little bit about the complexity of buildings, and we're going to have a little bit about buildings as a system. So I hope you all enjoy it. That's it for me, and we can move on to the researchers. Thank you.
Thank you, Pasi. And we realized just by listening to you how ambitious this huge project is. First, you will meet Beatrice Stolz. She comes from France and will, in her PhD research, promote a holistic evaluation of architectural qualities, affecting social values and supporting a circular development of neighborhoods. She completed 2 master degrees, one in architecture and the other in the science of sustainable architecture. This gives her concept an artistic approach to our built environment, combined with the necessity of developing sustainable solutions to reduce emissions. Please, Beatrice, your stage is yours.
Thank you, Randi, for the introduction. Good evening, everyone. Thank you for being here tonight. I will just launch my presentation. Yeah. So tonight, I'm going to talk about my research, architectural qualities for circular city. And in my research, I'm taking a holistic approach to values of the built environment. So hello, this is me. And as Randi mentioned, I'm from France. I have a background in architecture. And obviously, since I'm an architect, I'm very interested in buildings. But not only. What I also think is very interesting is to understand people and how people relate to their buildings. How do we value our built environment? Do we have power to retain values of the built environment? And also, how do architectural qualities all around us influence our behaviors? That is why in my research, I'm asking this question. How can architectural qualities support circularity in cities? So, as my research happens to be in Trondheim, the first step was to try to understand what type of buildings do we find the most in Trondheim. So I started to collect a lot of data about buildings that were registered in Trondheim's Kadaster, and I could find some information about the type of buildings, the number of square meters, the building date, the location. And then I tried to visualize it and to see, okay, in Trondheim, we have quite a lot of low-density housing, which are enebolig, tomannsbolig, firemannsbolig. We also have more recently and more higher density housing. But we also find a lot of schools, kindergartens, high schools, university, and also bigger structures like office buildings, industry buildings, sports hall, for example. And then I wanted to see where all of those buildings were located in the city, and I wanted to see if we could find some patterns, right? Some building patterns. So here you have all building types all together, and you can already start to see how the city is built. You can already start to see where the bigger structures are, and which areas are more dense around the city center, for example. You also see this curve here with bigger structures. Now, if you only look at low-density housing, you can see that they're quite spread all over Trondheim, and it's hard to define one singular pattern. If you move to higher density buildings, you see they're less, and you can start to see a little bit where they are. You can start to recognize some patterns. And now, if you move to even bigger structures, like office buildings and industrial buildings, you can really see the patterns. So down here, bigger structures along the river, before Gløshagen, in the city center, where you have a lot of office buildings, and this curve around here again. So with this, I wanted to push it a step further and to understand how the city was changing and how the city was evolving. So I continued my data collection, and I got some new information about all the buildings that got demolished in the last 5 years. And I got the same type of information, so square meters, date of building, also date of demolition, type of building. And then I could compare the number of square meters that were getting demolished and the number of square meters that getting built in every areas of Trondheim. And then I could start to evaluate how the city was changing. So here I made a color scale, and you can see the darker areas are the areas that are changing a lot recently. So down here, where we found a lot of office buildings and bigger structures, it's changing quite a lot. But also here, we find again this curve that we saw before, this pattern. Here, a lot of industrial buildings are getting demolished. Here in Byåsen, it's a lot of low-density housing getting demolished and higher-density housing, like apartment blocks, getting built. And then when the color scale is quite bright, it means it's not changing so much. So, for example, Midtbyen or Singsaker, right? So I could start to understand that the city is very complex and everything happens somewhere, not at the same time. But then I wanted to dive a little bit deeper and to try to see, okay, if I look at every building types, what is happening? So with all the buildings, among all the buildings that were demolished, I wanted to see the age or the lifespan when they got demolished. If we take a low-density housing, the average was 61 years. Now, if we move to office buildings, the average goes down to 43 years. And if we move again to industrial buildings, the average is 29 years. So you can imagine for a building that has maybe at least half the amount of material lasts 2 times longer than industrial buildings. So then I started to ask myself, why is this happening? And most of all, how is the built environment valued and by whom? Who is taking the decisions to demolish or to retain the buildings? So now that I'm mentioning again the notion of values, I feel like I should explain it a little bit more. Take a building. A building has many qualities. And every quality generates a certain type of value. So you can find some values according to the building materials. So where do the materials come from? How do they get to the site? How do they act together? What are their qualities? You can also find some values coming from the building components. So how many doors, how many windows, how many partition walls, where they are. Is there any elements in the facade that gives an extra value? Are they ornaments, added balconies, or etc.? You can also find some values according to the site and the location. How is the building connected to the rest of the city? What is happening around? Some people will value more green areas around the buildings, whether some other people might prefer a building with a lot of facilities around and a lot of things happening in the neighborhood. So it varies a lot. And then you also find some values according to the people who built the building, the people who designed it, the people who owns it, and the people who live in it, even just the people walking in front of it, thinking, nice building, or no, I don't like this one so much. Or even if they don't notice it, this also tells something, right? So now, all those values, you can think about them going from very material-centered, here, to more immaterial-centered or human-centered. And my job, or what I try to understand in my PhD, is how they affect each other. You can't think about those values siloed. What I'm trying to understand is that how those are influencing those. So who is making decisions? So with this and with the patterns that I could define in the first part of my research, I really started to understand, okay, this is very complex. This really depends on different areas in the city. And now I'm asking, could circularity principle evolve with the city's complexity? Which means that circularity might not always be about trying to close the loop everywhere, but it could also be about slowing down the loop in some areas, or even generating new loops in some other areas. So what I want you to remember from my research is that for each neighborhood, you have different qualities. Those qualities, they can generate values that are both material and immaterial, and they act together. And together, they have a power of action of implementing circularity. This power of action can be found at different scale. So it could be the material scale, the component, the structure, the envelope, the neighborhood, and even further. And all those scale, they might have a different circular potential according to the neighborhood and the people who live in it. So now this is my last slide because I like to visualize things. So I want also you to visualize it. Take two very different neighborhoods. Just by looking at the map, you already see that it's two very different types of buildings, right? Which means they have different qualities, different values, also different people that live in the neighborhood. So they might have different circular potential, and that's what I'm trying to understand. Thank you.
Thank you, Beatrice. Our next guest is Georgios Triantafylidis. He comes from Greece, and he is doing his PhD on the development of digital twins, tailored for circular cities. The challenge is to effectively capture, document, and update information about existing buildings, as well as to define the necessary information framework to drive the transition to a circular economy in the urban built environment. Georgios has been working as an architect for many years, and he has master's degree in design research and building information modeling. Please, Georgios, the stage is yours.
Just give me a second. Okay. Okay. Thank you, Randy, for the introduction. Hello, everyone. Thank you for being here. I'm Georgios, and today I will be talking about complexities in general, about buildings, how we can analyze them, how we can document them in form of 3D digital models, and in order to arrive to informed decision making. But first, I'd like to take you to a short trip to Italy and to my first studies in architecture. So here you see on the map, this is a map from the 16th century, and in the middle you can recognize this round form that already gives an insight about what pre-existing condition was there. That means that in this case the new buildings were built on top of a Roman theater by reusing existing foundations and by reusing some parts of the existing structure. Again, if we look at the situation, how it looks today from the map, we still, after so many years, we can still recognize the pattern and the traces of the past in the city. And what I found really fascinating is how we can tell stories about how cities evolve in time, while at the same time the sensibility of how we can value the pre-existing condition and how we can reuse pre-existing materials that are still in power. So to make things even more clear, here we can see another picture of a reuse and adaptive reuse of an existing structure, and we can recognize many different layers that are built in time. So we see the original ancient theater, then there is, instead of demolition, people decided to built with different materials, but again following the same form. And then on top we see another layer of new functions. And so again, the idea is how we can, in time, not only tell a story about how cities evolve, but at the same time how we can still value and reuse existing materials and existing structures. The question is now, for us, what are we doing today as building industry people? Are we following similar trends? Are we completely isolated from this way of thinking? So the fact says actually that the way we design, we build, and we operate buildings nowadays, it's responsible for very high consumption of energy. At the same time, it produces a lot of CO2 emissions and other toxic gases and substances. While at the same time, the way we build and we think about buildings, that we need to demolish them so that the life cycle of building is reduced. So we don't have buildings from the ancient times anymore, but after 60 or 80 years, they are demolished. So, and together with the high demand in new buildings, that means also that the way we treat existing buildings is like producing a lot of waste. Again, for producing all those building resources, we consume a lot of fresh water, and we are consuming a lot of virgin resources by mining them from the mountains and so on. But then to get closer, this is Trondheim, and as Beatrice was saying, a city is like a result of many different neighborhoods, and those neighborhoods are developed in many different time periods. That means that we have a high diversity of buildings in different areas, different ways of building and construction, different understanding about how a house might look in different historical periods, and also different use of materials. So the question is now, again, if we look closer to a neighborhood, for example, we see that we have many different kinds of buildings, different kinds of typologies, that they use many different ways of construction and material. And the idea for us now is like, if we talk about the city scale, how we can document all those complexities and heterogeneities, and how we can store this information in a way that we can actually go back to it and have a kind of informed decision making, as I said in the main introduction. So what I'm trying to do in my first part of my research is like, okay, we talk about data and information, but the question is, for me, I start backwards and saying, okay, we have already enough information. What can we do with this information? And in order to test where are the limits, what we're still missing and what we still need, and then go back and say, okay, now I'm missing this information, maybe I should get it in that way. So instead of just producing information, I would like, in my research, what I'm doing is actually to first see what we have, what we can do, what we are missing, and then after we decide that we are missing certain things, then we can go back and search for it. As a second part of my research, I will try to focus on the most common dwelling typologies in the city, and try to understand and to create, like, to assess and to systematize the materials that are used in the different typologies in different periods. And then the idea from this is to come with conclusions and try to say, okay, if a building, a single family house building from the 70s in that area is having this material, then can we say that probably then a similar building with similar characteristics has the same use of material, so that we then can upscale in the city level. So then I will give an example of, this is a typical house from the 70s. This particular house is in Vestlia in Trondheim, and we tend to call those simple form buildings as a box, because we think that they are just too simple and too banal and they don't have anything to say. The truth is that even this box has a lot of complexity. That means that this is not just a box, but it has many, many different elements. In this case, we have staircases, slabs, walls, facade, interior and exterior walls, railings, balconies, and so on. And this is not the whole story yet, because every one of those elements has even more elements in it. So if we take as an example only the single kitchen unit, we can say that it is the result, let's say, of many different elements, and those elements again have many different sorts of information. So the question is, how much of this information do we need in order to assess whether and to what extent and for what purpose we can reuse those building elements or materials to do what? And also, how do we store this in a proper way so that we can have access to it and share information among all the different stakeholders that are taking part in the decision or in the building industry in a city? And of course, you understand that this is, if we talk, this is the complexity of one single room in this case, and it's not even the whole information. So if we try to assess what's happening in the whole city, then we need to find a way to somehow systematize all this kind of information. So what is my goal? My goal is at the end to try to understand how the material in the city is released, like what is the availability, and how we can calculate, or not to predict, but somehow to have an idea about how much material do we have in a certain time, in a certain place, so that we can start planning and designing by the material that will be available in the future. So in this case, let's say that we can map that those buildings are going to be demolished in the next 10 years. So we know where they are. We have information about their materiality, so we can calculate how much material can we reuse for future buildings, and then we can call them the donor buildings, because they will provide the material for the next new building to come. By having this information on time and before demolition, we can also have information, more informed decision making about how much material will be available for direct reuse in the new scenario. Like, let's say that if this is a new area that is going to be developed in the city, and also how much material needs to be remanufactured before it can be reused, and how much material can be recycled, and how much material we can't do anything, so we have to throw it away. And at the same time, we can also possibly have a calculation about what is the best scenario in this case. So does it make sense to bring the material from an existing building here to here, or is there a shorter way so that we can also reduce the transportation? So then the idea is that to create new buildings as hosting buildings that are hosting the existing the materials from the pre-existing buildings. So the overarching goal for my PhD is how we can move from a mining of resources attitude into the harvesting of resources attitude. Thank you.
Thank you, Georgios. Then we proceed with the third PhD. Niels Dietrich has a background in both philosophy and environmental engineering, which he studied in Germany and at NTNU. His research revolves around materials in building stock, quantifying material flows at the stock level, assessing impact of reuse and construction, and developing scenarios for a more sustainable built environment. Niels is a PhD in the Industrial Ecology program at NTNU. Please, stage is yours.
Yeah. Then thank you, Randy. Hello, everyone. Then it's my job to finish off this round of presentations from Circular City, and I will do so by telling you about tracing materials in the building stock and building dynamic systems to further circularity in the built environment. Now, if we consider the city the center of the modern industrialized life, it's also the center of all the impacts and emissions we cause to the environment. And with all of those, I mean going from global warming, biodiversity loss, resource depletion. The majority of that comes from the city, but not directly. Around half of whatever of these impacts you take is caused directly in the city, and the other half is not caused directly there, indirectly somewhere else. You produce products and transport them into the city, and those impacts occur somewhere else, but they're caused long-term by the city. This is what we call indirect emissions. And the majority of those indirect emissions are caused by the materials in the city. And by those materials, I mean the dozens of tons of steel and concrete and bricks and timber that are in the buildings around us, for every single one here in Trondheim. Now, if we consider these impacts that are happening right now this year, they're not really caused by the existing stock. They're caused by the buildings we built today and the buildings we demolished today. By the materials that we require, the virgin materials being put into the building stock and the materials being demolished and then requiring some landfill and end-of-life treatment. Those create all these impacts. Now, if we systematize this a bit more, then we can talk about the building stock, the abstract amount of buildings around us. This is what gives the service, the function of shelter, where we live, where we work. We have the inflows into that stock, new buildings, outflows, old buildings that we demolish. We can study the interplay between these inflows and outflows and the stock. And then if we do this, we might look at something like this. This is a matrix where you can see from top to bottom the time. So we will look at different snapshots of the stock over time. And on the right, from left to right, you see denoted the time that the buildings were constructed, the cohort. Let's start with an empty stock in the 1900s, so we just pretend there's very few buildings there. Might have a bit of inflow in that year. So you see inflows on the left. They add up to the stock. This is our total stock right now. 0 outflows. Next slice of time, more inflows, bigger stock. See the stock growing and more stock accumulating. And at some point, when the buildings are old enough and they lose their value, and this is with a lifetime of typically actually over 100 years for most of the buildings, we'll see that some of the buildings will exit our stock. We still have inflows, but some buildings exit. And what we see here, this is not a random building from the entire stock. This is typically one of the older buildings. So it's the older buildings leaving the stock, and this will keep on going and keep on going. And what we see here is that the outflows effectively just catch up with the inflows from about one lifetime of the buildings ago. This is an extremely simplified model of what's actually going on there. In reality, if we go back to Pasi's story, one of the 1900s buildings might just be the main building of NTNU, and I hope, and I'm pretty sure, that it will not be demolished anytime soon, or maybe ever. And this is one of many, many factors that contribute to the complexity of how we model the dynamics of this system. And even if we manage to estimate the outflows that we have here correctly based on the historic inflows and lifetime parameters, we still have to deal with the stock. And the stock is effectively given, since it's given the function, by the demand for a certain service. Buildings, for living, for working. And if we have that and the outflows, then we can maybe correctly predict the inflows. And all of this is the topic of dynamic modeling here. Now, to give you some context for Trondheim specifically, these are proportions that we might see. 1.6% inflows of the total stock, outflows of 0.3%. Recently, still growing stock, or actually still growing stock. These numbers change depending on which building type you look into. But for perspective, these very small amounts of inflows and outflows are what causes the majority of the indirect emissions. The in-use stock causes the stock causes the in-use emissions. These tiny amounts of inflows and outflows cause a lot of the indirect emissions. Now, what does that mean for us? Well, if we want to study the emissions that we have, we need to get a good map of all the buildings in Trondheim, meaning what Beatrice talked about, neighborhoods, all the neighborhoods in Trondheim, the old and the new, all the buildings, and then try to figure out the materials and the components and the impacts related to those for those buildings. How do we do this? Well, we're not going out and measuring by hand all the 70,000 buildings. That would not be smart. Instead, for some of those buildings, as Georgios showed you, we'll design some nice digital models, and from those we can then hopefully extract the materials and the components. We can do this for a bit of a sample of those buildings, But as a reminder, the majority of the stock is old and predates digitalization in the construction architecture sector. So this is tedious work. So our sample should be representative, but it won't be exhaustive. So somehow we need to upscale from having a small sample of information, of good models, of correct data, to having materials and components for all of those buildings. How can we do this? Well, depending on time and effort, multitude of options are available. Can go from relatively simple models where we just have an average. We assume all the buildings have a very similar amount of material per useful square meter, over to archetypes where we pick out a couple of representative buildings, assign every single building one of those archetypes, have material intensities for those, multiply. We can have help with designing these types. If we have prior information, some metadata on the buildings, we can cluster them, design our types based on that, do the same work. We can try to go for full machine learning models where we predict building by building based on widely available data like matricule, the cadastre of Norway, street view, other data that we can measure easily and exhaustively. Or at some point in the future, all of those buildings were built, were documented at some point. If this information is well maintained and documented, we might just at some point be able to directly extract all of this somehow. Now, in Circular City, we're somewhere in the middle here. We're starting with archetypes. You heard Georgios talk about this, and finding types that are representative. We try to make this in a way, these types in a way that they're not just representative on our gut feeling, but also from a statistical viewpoint. And in the very end, we try to go for some building by building prediction of the materials. That is a tough job. It includes a lot of math. It's a lot of data management and coding. So why exactly do we do all of that? What is the goal? Once we have mapped correctly or accurately enough the inflows, the stock, and the outflows that we have in Trondheim, we can consider what Georgios also already took a bit away, right? How do we connect the outflows to the inflows? Donor buildings to receiver buildings, but not building by building, but for the entire stock, for those 70,000 buildings and thousands of buildings that are getting demolished and constructed every year. And this, not just for today, but for some years in the future, a multitude of scenarios, different boundary conditions in policy, society, economy, and also for different technologies that we could apply to actually reuse and recycle more of those materials. The goal of this is very simple to the total goal of Circular City. Twofold. One, directly engage more private and public actors in promoting circularity today. There are platforms out there for reuse and recycling today. And second, enable more research, and research especially from other fields that are tied to buildings, to promote and research circularity, our vision of the Circular City. Thank you.
Thank you, Niels. It's quite overwhelming to have all these perspectives, which we probably haven't heard so much about. I will ask all the candidates and Pasi to come to the stage, and maybe we hopefully will have some more light here. And now I will invite you to come with questions, reflections, or input or output for concerning a fruitful dialogue here now. We have someone with the microphone in the hall. Yeah. So you just raise your hand, and so we say, here we go. No hands.
Okay.
Please, we start here. Yeah.
Thank you. My name is Helge Brattebø, and I have a hand because I've done some research in this area myself, and thank you very much for nice presentations. And the way you present your methodology, the approach of doing research in order to understand and to document actually what the system, what characterizes the system, is both fascinating and I think needed. Question to you, Beatrice. You said, if I remember correctly, try to understand how immaterial values could influence the material values and how we relate to them. Yeah. Of course, we would like to conserve more buildings, value the material values. However, reality kind of tells us that economics and profit dominate all decisions out there. You have project developers and so on. And you have short-term thinking, and profit is so dominant. So, how would you then, when you are trying to understand the values and how values are, let's say, of importance, in a situation where economics and profit dominate, how would you go about that?
Yeah. Thank you for your question. Actually, I was waiting for this one. So, very good. Okay, because I didn't mention economical values, and it's a little bit out of my range in my PhD. Although I know it's a big driver, and I think today, as it's a very complex system, it's really hard. So it's really hard to know where everything is and how accessible are our materials. And of course, I try to simplify it a lot, but it's way more complex than that. But we're trying to make it easier. So maybe one day there will be a switch, and maybe it will become more accessible economically to reuse material. I think for now it's also a question of, because it's very time consuming to look for resources, to understand what we can reuse, where, so people probably don't want to waste their time with this. But I was thinking, so not with the building industry, but for example with the clothes industry, it's now very easy and way cheaper to buy secondhand clothes. Maybe one day it will also be the case for materials and from the building sector. So today it's very easy for some industries because we know where to find things. It's well documented, and you can just Google it and find some things. It's not the case for materials. So I hope I can answer to a certain extent to your question, but hopefully it will get easier with time. And yeah.
Yeah. Yes, are there more that would comment? Yeah, please. Please.
If there's any politicians here, we might have some ideas about, policies that connect reuse into other economic values. So, come talk to us.
But one little thought I get also is when you talk about this, there are stakeholders in all projects, and very often the economics and the power stakeholders, they are trumping everything else. But is there any discussion in your disciplines, or who's going to be putting some economic value or some power into sustainability, the mindset of sustainability into the whole sector? Is that because if it isn't put a value to it, how are you going to compete with the obvious values like power and economics and all what we see trumping everything? Is that a dilemma for you, or what do you think?
I think we need a new PhD for that.
Yeah, good answer. No, I think the building industry is changing quite rapidly in this regard. We have several startups in Trondheim. Very nicely, quite a lot of them come from NTNU students starting up because they think they have new mindsets. They think differently about the reuse of materials, and they want to push that agenda. So I think when they start doing that, they also force the bigger construction companies to follow, because they do have a better message, a better narrative about their future-proof business model. And also, obviously, here we have the EU taxonomy, Green Deal, all these mechanisms in place that now are more and more in favor of sort of the startups. Obviously, there is a power misbalance between the big companies and the small ones, but seems like they're trying to collaborate more and more it seems like this message is sort of coming across. In Norway, maybe in the Nordics, globally, maybe a bit further.
Okay. Yeah, here there are two hands. I think you were at the same time, so you just agree who is first. You will have the microphone.
Thank you. My name is Jan. I'm a postdoc at the Industrial Ecology program at NTNU. So thank you for the nice presentations. I'm going to direct my questions to the BIM modeler. So basically you discussed that if we're going to reuse or either building components or materials, then you need to take it from somewhere. A demolished building, for example. And one thing is when buildings hit the end of their lifetime. Another could be that, in fact, buildings become vacant because of population decline. So I don't know if you have thought in this direction. Or in the next half a century, for example, if rural-urban migration might cause population decline in rural areas, should we bring materials from these areas to cities that are growing, or even other countries?
Okay. Well, thank you for your question. I don't know if this is a question that I, as a BIM modeler, should answer, because this looks actually in the bigger scale. So I think that's more Niels. But if you ask my personal opinion, let's say that the idea is now how we can have information about where the resources are, if we can reuse it, for what purpose, when we can take it. And then if we know the location, then we can actually have another kind of assessment based on like how much transportation, like in terms of CO2 emissions or cost, it takes to bring something from South Norway to the other edge of Norway. So does this make sense at all? The answer is probably not. So yes, I don't know, is this, did I answer your question?
I can
okay.
Also try a bit. But for that, what that primarily requires is a good information flow, knowledge about the availability of these components and these buildings, and that's especially important before they deteriorate too much. Right? Vacant buildings, especially in Norway, tend to be neglected for decades before then just collapsing or being torn down. Often purposefully so, because they're protected. You can't actually demolish them unless they're becoming a hazard, so you let them deteriorate until then. But the concept is not very new. There has been in Trondheim, there has been a row of fires in the 19th century, and the typical response from inhabitants of Trondheim has been to go to the countryside, to not demolish, but carefully disassemble houses, bring them back into the city center. This is what we're seeing here today. This has been happening, but there is a gap, not in the last century. This is not a practice currently done a lot. And I think that is mostly due to one's need, constructing with a possibility to, like, what is it called? Design for disassembly. That would be the keyword here, right? But then mostly the information. Like we would need to know when one of those buildings becomes available, vacant in the countryside, which has much poorer information on average than the city.
Yeah, there was another one. Yeah, please.
Yeah, my name is Jochen Köhler. I'm professor in structural engineering. Actually, I'm part of the project as one of the supervisors. So I'm asking a little bit like devil's advocate.
Okay. That's good.
I'm actually, of course, very fascinated, and I'm very pleased with your presentation. So you did a really good job to present our project. It was really very good. But I'm a little bit concerned when it comes to the implementation of all our ideas. The most sustainable building is the one that is not built. So it's many of our ideas are a little bit across the ideas of this infinitive economic growth. So what do you think are the main barriers that come in the way for implementing broadly these philosophies we are trying to advocate?
Yeah, please, who will?
Okay. So what are the barriers?
The main
main barriers
for implementation of circular economy in a... Okay, I think it's first the acceptance. Do we really want to... I think because what Beatrice was mentioning before, second-hand clothes are cheaper, but still not many people want to buy second-hand clothes. So is this acceptance still in society something that do we want to, or how we imagine that those reused materials will be, or the security about them? So can they last for 20 years, 50 years, 60 years as a new one? So there is a lot of insecurity in this terms of like, and people of course would prefer to say, okay, I won't buy something that is used already because it's going to last less and I'm paying enough money. So I will just invest a bit more to buy something that theoretically will last more. So I think this is one barrier, the acceptance from societies in general. So how we imagine that those things are, and yeah. Also the legal issues and all those, like how politically we make decisions about how we facilitate certain decisions instead of others. I think this is also something because, of course, if we want to make such a radical, let's say, change from consumption into reuse of something, then many people will lose jobs, many people will lose opportunities, money, and so on. So if there are people from certain industries that are having like high, let's say, impact on the decision making now, how societies will move and how consumption is based. So if those people are stronger than the opposition, then of course it's also hard to have another option. Yeah, I think that's from my...
Also,
yeah, please.
Also, as we mentioned already, the availability and the accessibility of materials. For now, for us, it's more about the availability and the accessibility of data. But once this is solved, and once we want to go broader and bring it to everyone, it's the availability and accessibility of materials. And yeah.
And the cheap price of new materials.
Yeah, right. Yeah.
Niels, would you like to give a comment? No? Pasi? No? Okay. So you got some input? Yeah, great. There's a hand more here, and a few, there are several in the back. Yeah.
Marina Zabrodina, Trondheim Municipality. So about second-hand cheaper. Right now, when building materials and elements are concerned, it is not cheaper. Well, however, Trondheim politicians are willing to promote it, so we get some financial meals dedicated to use to this second-hand building material and elements storage. So, but I think that by now it's mostly economical and quality issues, guarantee issues. Well, not really acceptance because, well, there are many projects in Oslo and other cities with second-hand building elements. Very fascinating, but it's still, well, like singular things because of all these barriers.
Thank you. There was some besides you. Yeah, there were one more behind there.
Thank you very much. It's so interesting. I'm very excited about all what you have presented, all the four of you. Beatrice, you mentioned, my name is also Beatrice actually. You mentioned the second-hand shops, and I can tell you, and you know probably that also, all over Europe, they're popping up everywhere. It is so popular. It's become a real trend. It is crazy. People want to buy second-hand. They're young people, and it is hugely popular, in fact. So I can imagine, because you have now thrown the seeds about your scientific projects, about this sustainability and reuse of materials. This will come, and I actually all of a sudden could think about a huge chain like IKEA, an IKEA chain specifically for used building material. You know, a huge type of thing, because it is the future. We have to reuse the material. And then if you have a system like that, like IKEA, you have also catalogs, everything is available. You see it you click on it and you know exactly what's available and you can plan easily. I see something like that. So, please.
Oh, wow.
Yeah.
I think there were one hand there and one in the back.
Can I just comment on that one?
You want? Yeah, please.
Because what they were saying from the Trondheim municipality, this storage that they have, which is co-located with Brukom at Nyhavna, it's still small, but it is sort of getting there. And see the amount of people going and buying flower pots or stuff. And then we actually have a lot of collaboration with the municipality because they are actually trying to track all their building components. And we see that our project is, let's just say, we get goodwill. People like to work together with us because, one, we're an NTNU project, so they have trust in what we're doing. And the other one is, we're not alone. There's so many people, both from industry, public bodies, NGOs, agencies. They're all working on the same topic. So one of our main concerns when we discuss with others is let's work together and build a joint data set instead of everybody doing the same again and again and again. So I think that's probably one of the big things for us in the near future.
Yeah, please, next.
Yes, first of all, thank you for your presentations. I mean, it's not that easy when you're just 1 year into your project and you stand up at the scene there and have to talk like you own this, so my compliments for that. My name is Casper Box. I'm a professor at the Department of Design, actually part of the same faculty as the architecture departments. I know Pasi very well. And I want to ask maybe 2 questions into one, and maybe it's fair that Pasi answers it, because it's not something that you have researched. We often make a joke at the Department of Design. We say that designers design for others, while architects design for themselves, in a way. And I was wondering if, because it makes a lot of sense, right? You use existing materials, but would that be as fun for architects to design with stuff that you already know is there, that has been meticulously made available for that building that you are going to design, and then you might have not the same amount of freedom to build what you do. So my question is, would that be a barrier for this? And my other question would be, would it take a different way of educating designers, architects? Because, you know, it's like designing a new building with, whether it's old bricks or new bricks or old timber or new timber. Is that the same, or would that actually make a difference, and you would have to redesign the whole education system? So,
yeah. First, I'm going to be perfectly blunt. I don't think the architects have a choice, to be honest. This is the way it's going, unless you can design with used materials in the near future. Just to exemplify, we educate 100 architects, 150 architects from NTNU every year. We have about 8,000 active architects in Norway. So we already have a lot of architects that know how to design new buildings. Those we have. What we don't have is architects that know how to design with used materials and new buildings. I think revamping the education is a must. And sort of outside the project, we have started, so we are developing a sort of 2-year program now for circular architecture at the faculty, just to get into this. So it's probably going to be submitted to the approval process in November. So that means that there, hopefully you can run with it. But I will definitely say, if I can look at our students from our architecture faculty, they love used materials. Yeah. Almost all of our master's thesis projects now are very focused on transformation or the reuse of materials, circularity, energy upgrades. So there's a huge interest among the students. I just hope that they get into positions of power in the companies quite fast, so that they start making decisions for the companies.
We have one comment. Oh, yeah, no. No.
Can you in order?
Yes, thank you. I never saw it as less freedom, but I think when we're students and when we think about it, and when our professors are started to implement ideas in our mind about reuse and stuff like that. No, but I think we are taking it more as a challenge, and it's we become even more creative because we have to come up with solutions that actually can have a better impact. So I don't see it as a lack of freedom, but more as a better way to express ourselves and to show more creativity.
Yes, so again, I will reflect a bit on my own experience. So I did my studies in architecture in Florence, which is like a place where all the city center is like maintained. You cannot change anything. So in this place now we had to learn actually how we design new buildings inside this kind of setting, that you are not allowed to change the image of the city first. So that means also that there is no space anymore for new buildings inside the historical city. So that means that all the changes that happen in existing buildings. So I remember my school, it used to be like a monastery, then it was transformed into a jail, and it was transformed afterwards into a architecture school. And I could see, so there were like the pre-existing, like all the old, how do you call it, the places where they used to put the people in isolation. And that was the places where we students gather and design. So we sit with our laptops, and we could see the whole door, the whole setting was there, like the railings, that with everything. So I think, and then of course, when I was studying there, we were always looking like, but it was again 15 years ago or something. So we were watching what Zaha Hadid does and all those weird forms and all the software and everything, and we were fascinating. We were like, look, we are just removing small pieces of wall here and there, and look what the others are doing. So I think it's also like, by growing and gaining experience, let's say, that it's also it's a kind of market, in my opinion, somehow, how certain things are promoted in certain settings. So what is the trend in architecture? Is it better to have like these Gary buildings still? Is this creativity? I would argue that for me, creativity is like how at the end you can solve complex problems with less complexity. So how you can give simple solutions to complex issues. That's for me creativity. So I would just move this kind of how we train architects to do weird shapes and things that look creative into the substance, really.
Yeah.
Yeah, just Nils also have a comment.
I'm no architect. I'm sure the architects can handle this. But we had the question earlier of the speed, and Pasi was mentioning there are startups, there's incentive there to actually move towards more sustainability. But the architects are not where it stops. We don't build a building after the architects designed it. The architects design it, and the structural engineers make it safe. And this is right now the much bigger bottleneck. We're not allowed to reuse structural load-bearing materials. And there's also, this is a more conservative fraction of the building sector. So this is probably, right, even if the architects manage to redesign with existing materials, you need to be able to safely engineer those buildings then afterwards. I think this is, in my view right now, a bigger point of that. And to roughly give that and put that into perspective, the structural materials, so the load-bearing materials, are the most important part of the building. We can change the windows, we can change the cladding, and we do that quite often in renovation. But changing the core, the skeleton of the building, this is the massive amount of the materials, of the impact, and this is where right now we're kind of bound by law.
There is one person here with the yeah. Okay, you first, yeah, and then it's here. Yeah.
Hi, I'm Jaja from Industry Ecology. We know each other. And thank you so much for a nice presentation. And I have two questions. So, I mean, based on presentation, I understand is you guys focus a lot of materials and like building components. So my first question is, how do you, for this project, do you also look at about people or population? Because I mean, the buildings are constructed for people to use. So, like the batteries, I understand about you look at the people who live in buildings to decide the kind of like value. And so I also were wondering, like for Niels and Georgis, is you also look at building, look at population or person this perspective? So it's my first question. And my second question also, like Jan mentioned, like the rural area when people left, so the building will be like no people will use it, so it will be like just stay there. So how do you think about like when the kind of a building is still there, it exists, but no people use it?
Okay. Yeah. First question: who will give some reflections?
Yes. Okay,
yeah.
So you saw the presentation. So yes, I look at people. I think I know why you're asking this question, because you're working on the population that is growing, and what type of how can we deal with this? But I look more at I don't look at the growing population, but how people value their buildings, and also who are the actors in the building sector that are taking decisions. But I'm not sure the question was addressed to me directly. I think it was...
to me?
No, I think
okay.
Everyone.
Okay. Okay, so I'm not really looking at this, but what I'm looking is more like to have enough information about what is going to be available when, where, and then what. So, and then if this is enough to cover the needs, but what are the needs I cannot see. Maybe this will come from you.
Yeah, Pasi.
I just have to point out, because I know Jaja's work really well. Obviously, there are huge drivers in society that are going to govern a lot of the changes we're going to put into the buildings. One is the elderly wave. So can our buildings deal with the increasing amount of elderly people that need different things, universal design, for instance? And the other one is energy renovations, reducing the amount of energy used when the building is in use. These things will put a huge amount of pressure on our building stock in the next starting now, like today, and for the next 10, 15 years. So it's not that the people are static, not by any means.
Then we have a lady here. Please, you have been waiting for a long time now.
My name is Randi Nygård, and thank you for presenting your projects. It's very interesting. I think the big challenge will be the communication and the implementation of these thoughts. And to come back to Beatrice's presentation here, you mentioned a lot of parameters that you study, and some of those related to neighborhoods and people's feelings and togetherness and that sort of thing. Not more qualitative ideas than what you can really count. Or yes. And how do you think it will be possible to communicate those kind of things to builders? How do you quantify it? How do you count it? How do you present it? That's going to be your next step, isn't it?
Yes.
If I just may go on a little bit, I'm not an architect. I have been working in hospitals all my life. And you know, one of the big projects going on now is the new hospital in Oslo, where they have Ullevål Hospital, beautiful old brick buildings in lovely parks with lots of trees and green grass. They're going to build a new one. The psychiatric patients will be put up on the 23rd floor instead of being down on the grass. And then comes another aspect of circular architecture, because it's not only a matter of demolishing, but it's also a matter of reusing. I love the pictures that you showed from Rome and from Florence, where you have to keep the city structure. And there are so many beautiful buildings around that are just demolished. And it's good that you can use the building material, but can't you use the buildings? What they say about the hospital in Oslo now is that it's much cheaper to build new. There are new requirements for electricity, for safety, for isolation, for everything. And then it's easier to use, to begin from start. And that's probably what this will end up with. But isn't that also an important part? You mentioned it is in Italy. I hope it will be in Norway as well.
Yeah, thank you. Yeah, that's an example. When you mentioned the hospital situation in Oslo, that's a huge dilemma. I think that discussion has now been about 10 years in the public newspapers, and the waving forth and back and forth and back. Who will reflect on that dilemma?
Okay, I can try. So you first mentioned if I think about how to quantify my research about something that is more qualitative. So I get this question a lot, and we have been reflecting on it a lot, and yet I'm sorry, I don't have the answer now. But yes, it's something that we need to think about, and it's not so easy. Then you also mentioned about not necessarily having to demolish buildings, but reusing them. And I think that's what I tried to explain when I said that circularity is maybe not only about closing the loop, but slowing down the loop, which means that we should try to reuse our buildings. We should try to make them last longer, so we don't have to demolish them necessarily. Yeah. So it depends on so many different things, so many different values, and also so many different areas, the needs, and everything that is related to that. But yes, we know that it's not only about demolition and rebuilding with existing materials. I don't know if it answers.
Pasi, will you fill out?
Yeah, I really like this question. In the beginning, I said maintain, adapt, and salvage. It is in that order, specifically. Unfortunately, if we only look at the economics, as Helge was bringing up, it's often cheaper to build something that ticks off all the boxes, because there in a hospital there's a long list of boxes that you have to tick off. When you start thinking about the buildings the way we do, usually just keeping the old building will come on top. Unfortunately, there's a discrepancy between the incentives for the builders at the moment. But again, any politicians, we can have a discussion on what might be sort of frameworks. At the moment, what I'm a little bit more worried about, that most of the laws and regulations that govern this aspect is actually not initiated in Norway, but it's coming from the EU. So it shows that the EU is driving this. What I'm missing a lot is the Norwegian politicians driving this as well. We do have a bit of a difficulty there. No offense if anybody's here.
Okay, new hand in the middle there. Or and somewhere in the back first. Yeah. Please.
Robert. Hi, good evening, everyone. Christian Edwards from Henning Larsen and AHO, so I'm a little bit about to swear in the church, I think. Architects School in Oslo, where we've actually been teaching circular architecture and prototyping in the Arctic with reused materials. So it's not so much a question, but actually more of an outreach and a reflection, is that we're sitting with quite a lot of challenges or understanding of the challenges by having put into practice some of these pre-accepted beliefs of how we're going to put things together or how we're going to take things apart and put things together. And having drawn out nails for a week in minus 26 in Svalbard, I can tell you that there are some practices that need some development, both in the sort of pre-building stage and then afterwards. But it seems like if you're putting together a program now in NTNU, that this is a genuine opportunity for a bridge building exercise between our schools. And I'm sure we'll be talking about this afterwards. But thank you for your presentations and the way that they complement each other on your working things. I think it's very evident for everyone to see. I guess we wouldn't expect anything less from Pasi's team. So thank you.
Thank you. There's one more hand I have seen. So maybe, yeah?
My name is Hanya Musho, and I really feel like maybe my comment is redundant now, because your presentations, wonderful, really impressive. They really made me think about the comment from yesterday when one of the people seated somewhere here said, what is transformative research? It's not about sort of relentless innovation in a particular way. And so I think you were, in all of your presentations, what was incredibly important to me as a scholar was seeing how you, as junior PhD scholars, are dealing with complexity, nuance, how you are asking these important questions. Well, maybe we don't need more modeling, more data. Maybe we need to reflect on how we use it. And going back to the question of implementation, I think the transformative power of your research is that you're changing also social values, making us pay attention to immaterial values that these different materials hold and these different buildings have. So a big thank you, and I think it's a great modeling for other PhD students, which gets me to my question, which is what got you to think in such complex ways and sort of to go a little bit against the grain, to think about, maybe minimal computing, not, sitting in your own corner and doing the modeling that you probably would be encouraged and maybe paid more to do.
So it's a question addressed on me now, I guess.
To all of you.
Okay.
Yeah, so speak up.
Okay.
Motivation.
Motivation. I think it has to do somehow with my professional experience, because people tend to ask about, when I used to ask, okay, what do you need? What is your goal? The answer was always like everything, or I don't know, or something. But then still they expect from me, or they used to expect from me, that I give a lot. So that somehow they are repressed and somehow they feel like what they pay so they got a lot for what they pay. So it's about quantities. If I give them one little sketch, maybe it's not enough for me to get paid the money that yeah. So it's always about, I think in my impression, we tend to think in terms of quantity. So we think that a lot means good. So I think that was my approach and to this thing. So I'm thinking like, yes, first it's, but also like, how to say, because, okay, another story. I enjoy really much cooking. So I'm always trying to find analogies with this kind of thing. And also, okay, being in Italy, I enjoyed a lot of food. And it's really surprising to see for me like how very little simple materials put together, they make something that it's like amazing, that you couldn't even imagine that those three things make this dish. So for me, this is the core, I think. First, to define what do I need. Second, what do I have? Is it enough? Not. Okay, if it's not enough, then I already know what I am missing, and then I go out and search for what I'm missing. I'm not just going around collecting things that I don't need. Yeah.
Yeah, Beatrice, Niels? Something about your motivation?
Yeah, you cook very well.
Yeah.
I could.
Approved.
I approve.
You don't have to answer.
On the core motivation to model in like this higher complexity. Well, it's the next step. There's been, especially for me, like there has been. Helge mentioned Helge worked on building stock models before, and I think it's now we have more opportunities than ever before. In terms of both the data that comes in and the processing that we can do, and we have a solid foundation of theory there. And it's just really fun to set more and more on top of there, in order to get to more accurate results, to have the chance to validate more than was possible like decades ago when this started. And I mean, in the end, working together interdisciplinary in this means that hopefully there's even more benefits from doing all this work. So in the end, I'm not hoping to finish my PhD in 4 years and then whatever I did will be thrown away. But hopefully this will be in the Circular City project and spin-off projects for years to come afterwards.
Okay, then we have one last hand, and I think that will be the last, and you had the first question as well. So that will be the last question, and to finish this session, please.
Thank you. Okay, then I'm very lucky, actually. First of all, it's so inspiring listening to you, the way you respond and discuss, because you are all quite early in your PhD process, and you have one project, right? Beatrice, you have your project, and George, you have yours, and so on. And you are now discussing the context around these projects. And the context brings up so many dimensions, right? And we have to understand those dimensions in order actually to succeed and to have the motivation of what I am doing in my little bit in this puzzle. So it's very inspiring to listen to you. When you have characterized and understand these values, when you have the digital twin, when you have the data set to understand the dynamics of the system, we want change. We want to implement changes. Actually, we do want Beatrice number 2 succeed in having this IKEA. So this large-scale, let's say, mechanism that could make the circular city at scale successful. And I'm sure you have discussed not necessarily IKEA, but you have discussed what could be done. So I would like to challenge the three of you. What is your reflection on what is the most important thing in order to make the change happen? Thank you.
I think
please.
For me, but also related to my PhD, is to understand who has the power to make such a change. So that's why I'm trying to see, people living in different neighborhoods, but also people from the building sector or the municipality, who has the power and who wants to make a change. So.
And what will you do with them? Will you go and knock their door and sit on their table?
Maybe, I don't know. Be prepared. I don't know yet.
Georgios?
Okay, so what I think, first of all, I think, for example, the cost is an important factor to have like an impact, so to being able to implement this. And another thing with the data is like, okay, we ask for a lot of data. The question is like, maintaining the data is a huge cost. And the question is, if we are building something now that we want to use in the next 60 years, or I don't know, there should be people who are maintaining this. And it's different if you have 5 gigabytes or you have 50,000, I don't know, terabytes. Yeah. So the complexity also from this point of view. So how do you make something available, that it's enough, easy to maintain, not high in cost, not too complex for people to understand? Actually, what do we need? This is the main question. What is the minimum of that? And then,
This?
For me, very clearly change in public perception and attitude towards buildings and the use of buildings as something that can occur consciously. When we think about it, we always have a lot of debate about the transport, right? And the change and the transformation that we have in transport, not choosing to take the car instead taking the bike. And this can be a very conscious choice for many people. But we don't talk a lot about we don't have a lot of chances to determine our buildings, right? We move a couple of times in our life, maybe we buy a house once or build a house once. But this is probably one of the most important points in life where you can make a huge change, and this needs to be like a very conscious thing that's brought up and that is a public perceived thing that as a conscious choice, where we live, where we work, how we either demolish or refurbish or rebuild buildings. And I think that is currently not so much on the minds of the broader public.
Then I will say thank you so much to the candidates here, to PASI. Some of us know quite a lot of the process that has been developing into this presentation and performance at the stage. And I think all of you have really reached a very, very good, you got a lot of comments on that. So that, clap for that. Secondly, thank you so much to the audience, and it's really inspiring being moderating and creating these events, because there are so many engaged and interested people coming here, and you are contributing so well to this discussion. And at this NTNU Kveld, there was somebody saying it's so great to be here and to think loudly. Think together loudly. Where can we do that? And he didn't know any other place. So I think this is very fruitful. We don't have the facet answers, and that is not what we are aiming for. But to share what we shared together this evening, I think that has a very, very great value. So this project, as Prorektor Tore Grande told us, this is 47 PhDs that will work for 4 years. This was the group 1. We had one yesterday and you today. So that is the first group. And all 47 of them will come here and appear with new, interesting lectures. So I welcome you back later on when we come to second, third, and fourth round. So please enjoy the rest of this evening and be safe in your back home.